All right, we are continuing with Chapter 6, which deals with concentration. Section 6.3 is going to deal with concentration. And now, we're not talking about your focus, concentration. We continue to talk about solutions and concentrations of solutions. Now, what is concentration? Concentration is a measure of how much solute is dissolved in a solution. So how much is dissolved in a solution? Now, there are lots of ways to measure concentration. You might have heard about something like parts per million or parts per billion. This is an example of concentration. For example, it's law that our city water is tested daily for a variety of chemicals such as lead and nitrates and everything like that. There's an acceptable amount of how much that can be in the water, or an acceptable amount of how much can be dissolved in our water. That's our concentration. That's measured in parts per million and parts per billion. For our chemistry purposes, the units we like to use are either grams per mole or grams per liter. We are going to focus on this grams per liter. But concentration is how much of something is dissolved in a solution. So how much is actually dissolved? And really, there's three types of vocab words that we can associate when we are talking about types of solutions. And the first one is a saturated solution. And a saturated solution is a solution that contains the maximum amount of solute. So it's the maximum amount. And when we talk about this, think about when you've ever dissolved something. Let's say when you made Kool-Aid before. All right, most of you, I'm guessing, have made Kool-Aid or hot cocoa or something in which you've taken water and had to dissolve sugar or a powder packet in it. Saturated solution. And by the way, when you drink Kool-Aid, you're going to add cups of sugar to it, right? You're not just going to use the flavor package. You're going to add cups of sugar to it. Well, my brother liked sugar a lot, and when he'd make Kool-Aid, he'd add 5 cups of sugar to the solution. What do you think all 5 cups dissolved? No. In fact, I think he could get about 2.5 cups of sugar dissolved. What would happen to the other 2.5 cups? It would just sit there on the bottom, right? Because the water couldn't dissolve it. So at 2.5 cups, the solution is saturated. That's the total amount that it could hold. So that's a saturated solution. Then we have an unsaturated solution. All right, my mom would always tell my brother, "Stop putting so much sugar in your Kool-Aid." Well, this would be an example. If my mom got her way, she'd have an unsaturated solution. We know that my brother likes to add 5 cups. We also know that pitcher of Kool-Aid could only had 2.5 cups of sugar before it was saturated. Then, all right, my mom would only add a cup of sugar. So a cup of sugar would be what we call an unsaturated solution, a solution that contains less than the maximum amount. So 2.5 cups would be a saturated solution. 1 cup would be an unsaturated solution. Then you would get to my brother, who would get his way, no matter regardless what, and he'd add 5 cups of sugar to his Kool-Aid. 5 cups of sugar would be a super saturated solution. That contains more than the maximum amount. Now we're going to talk about supersaturated solutions because there's actually a pretty cool and unique thing about supersaturated solutions. Does anyone guess how my brother, if he wanted to have 5 cups of sugar dissolved in his Kool-Aid, could have it happen? Well, it goes back to the last section that we just talked about. If he heated his Kool-Aid, that solution could hold more than it could if it was just cold. He could have hot Kool-Aid with 5 cups of sugar in it. How disgusting would that be? All right. So saturated, unsaturated, supersaturated. Saturated holds the maximum amount. Unsaturated holds less than the maximum amount. And supersaturated is a solution that contains more than the maximum amount. You can kind of compare these to Goldilocks and the Three Bears. Saturated's just right. Unsaturated's too little. And supersaturated's too much. So you can kind of think of it like Goldilocks. Saturated's just right, unsaturated's too little, supersaturated's too much. Now, when we talk about concentration, we are going to have to do some math when we talk about concentrations and concentrated solutions. And we have to figure out concentrations. Now, the easy thing to do here is the equation for concentration. Concentration is equal to grams of solvent or solute divided by liters of solution. So I'm going to kind of put this in a circle chart to make this kind of pop and make sense. So if we have a chart here and we tee it like this. We're going to have concentration in one side, grams on the top, and liters on the bottom. Now the cool thing about this is anytime you want to solve for one of these three, just cover up one of those three. So for example, if I want to cover up, or if I want to solve for concentrations, I'm going to cover up concentrations. Well, concentrations is equal to grams divided by liters. If I want to solve for grams, grams is here, I'm going to take concentration times liters. Since they're side by side, I'm going to multiply them together. And lastly, if I want to solve for liters, liters is here, I'm going to take grams divided by the concentration of the solution. So just a little something to kind of help you out figuring out concentration. Concentration is equal to grams divided by liters. So concentration grams divided by liters. So what do we have here? We have a 3.5 liters of solution that contain 90 grams of sugar. What is the concentration of the sugar solution? Well, anytime we do a problem, it's important to write down what we have. So what do we have? Our liters, we have 3.50, and our grams, we have 90.0. And we are trying to solve for concentration. Right, concentration has a question mark there. So let's go ahead and solve for that. Well, we have grams and we have liters. We're trying to solve for concentration. So concentration is equal to grams divided by liters. Well, now we're essentially going to plug in chug. We're going to plug in our 90.0 grams divided by our 3.50 liters. And we're going to get 90 divided by 3.5. And when we do that, that equals 25.7. And our unit for concentration, the one that we're going to deal with most of the time, is grams per liter. So grams per liter. So concentration, the unit is grams per liter. When we talk about concentration of solutions, we focus on labeling it as saturated, unsaturated, or supersaturated, and then we can do math to actually figure out the exact concentration of a solution. This is Mr. Klennert, and I'm signing off.